Whenever you provide a measure of center, you always want to couple it with a measure of spread. So for instance, we have two data sets here, data set 1, data set 2. We want to calculate the median for each data set. So remember, we list each of these data sets in order from least to greatest. So the median in data set 1 is 5. The median in data set 2 is also 5. But even though these two distributions have the same median, they could look very different depending on their spread. So what we want to do is construct a quick dot plot for each set of data. So we will need a number line from 1 to 10 for each data set. Basically, all we're going to do is we're going to put a dot above each value. So there are 4 1s, 1 5, 4 10s. For data set 2, we have 4 4s, 2 5s, 3 6s. So as you can see, even though both data sets have the same center, their spread of data is very different. Another word for spread is dispersion or variability. Here are some ways that we can measure this dispersion. The first way we can measure it is the range. The range is the maximum value minus the minimum value. As you can see from the formula, the range only uses the smallest and largest numbers in the data set to describe the variability. This can be misleading because sometimes the smallest and or the largest number in the data set is an outlier, which can greatly change your range. So we can improve our description of the variability by also examining the spread of the middle half of our data. So the way we measure the middle half is using quartiles. So our upper quartile, also known as Q3, is when the data is ordered from least to greatest, and we find the median of the upper half of the data. So in order to do this, we first find the median of the data set, cover it up, and then pretend like it's not there, and then we look at the upper half of data and locate the median. A similar process is used for the lower quartile, what we also call as Q1. When data is ordered from least to greatest, it is the median of the lower half of the data. So once again, when you find the median of the whole data set, you cover it up, pretend like it's not there, and find the median of the data set in the lower half. We have also the interquartile range. This tells us the range of values for the middle half of data. It is the difference between the 75th percentile, which we know is Q3, and the 25th percentile, also known as Q1. So basically, the interquartile range is Q3 minus Q1. We also have something called the 5-number summary. 5-number summary consists of 5 numbers: the minimum, Q1, median, Q3, and the maximum. And finally, in order to determine whether a data set has outliers, we use the following inequalities. To be an outlier, a data point must be less than 1.5 times the IQR when subtracted from Q1. Or it also could be 1.5 times the IQR more than Q3. Anything larger than that value would be considered an outlier. So let's look at this first set of data. The first thing we want to do is we want to make sure we order this data from least to greatest. It's always good to go back and check and make sure you have all of the data points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. So we can see here that our minimum value is 10, our maximum value is 35. Therefore, the range is the maximum minus the minimum. The range of this data set is 25. Next, we want to find the lower quartile, or Q1, median, and upper quartile, or Q3. So what we need to do next is find the median. So the median, we know, is located halfway between 18 and 19. When I add these two together and divide by 2, the median ends up being 18.5. Once you locate the median, we pretend like it's not there. So this is going to be our barrier. I look at all the numbers to the left, and I'm locating the median of this lower half of data. And the middle number this time is 15. So this would be considered Q1. Then I look over to the right side. The median of these numbers is Q3. So lower quartile is 15, our median 18.5, and our upper quartile is 24. The interquartile range we said was the range of the middle 50% of data. So Q3 is 24, Q1 is 15, interquartile range is 9. So the middle 50% of data is only 9 units apart. Next, we want to know if this data contains any outliers. So our formulas for outliers looks like this. Well, we know that Q1 is 15, and we just discovered that the IQR is 9. Our Q3 is 24, IQR is still 9. In this case, we get 1.5 and 37.5. So to be an outlier, a data point has to be less than 1.5 or greater than 37.5. If you see our list of data, there is nothing below 1.5. In fact, there's nothing below 10, and there's nothing above 35. Therefore, there are no outliers in this data set. Let's do a couple more. Our next data set, we need to order from least to greatest. Excellent. So we see that we have our minimum at 301, our maximum at 352. So our range here is 352 minus 301 for a range of 51 units. Next, we're looking for our lower quartile, our median, and our upper quartile. So first we need to locate the median. The median is going to be the average of 328 and 333. So the median is 330.5. Again, we cover this up and pretend like it doesn't exist, and we look at all the numbers to the left. So to the left, we have 4 values, which means that the median of these 4 values is going to be between 311 and 314. So the average of these two numbers is 312.5. We look to the right of our median, and that means the median of this upper half of data will be the average of these two values in the middle, which is 342.5. We know that our interquartile range is Q3 minus Q1, which we have 342.5 minus 312.5. The middle 50% of data is 30 units apart. And that leads us finally to our outliers. Our outliers look like this. So our outliers must be less than 267.5, or they have to be greater than 387.5. As you can see from our list of data, there are no data points in this set that are below 267.5 or bigger than 387.5. Therefore, there are no outliers. We have one more example that I'd like to try on the next page. Last example looks like this. As usual, we're ordering these least to greatest. We have our minimum value, we have our maximum value. To find our Q1, median, and Q3, first we locate our median, which is right here at the center at 45. We're covering up 45, we're pretending like it doesn't exist for a moment, and we're looking to the left. There are 3 data points to the left, and the median of those 3 data points is 41. To the right side of 45, we have 3 elements, and the middle of those 3 elements is 57. interquartile range. 57 minus 41 is 16. And finally, we have our outliers. So any data point less than 17 or greater than 81 is considered an outlier. If you look at our data set, you can see that we do have an outlier. 82 right here fulfills the inequality of greater than 81, so there is one outlier. At this time, you should complete the rest of the exercises and stop when you reach the next video.